Hello students, in this series of lectures in the subject VLSI technology, today we will discuss metallization choices. So, what type of materials are used for different applications? In this lecture we will discuss that. Now first of all, what are the desired properties of metallizations for integrated circuits? So here are some enlisted desired properties that are required for the metallization process. First one is there should be low resistivity of the material. It should be easy to form. It should be easy to etch for pattern generation. It should be stable in oxide and ambient. It should be mechanically stable. It should not alter the device characteristics. Okay. It should have good device characteristics and lifetime. It should not contaminate devices and wafers. Okay. And its surface is smoothness should also be there. Okay. So these are the desired properties uh, of a material that is used for metallization purpose. But no metal satisfy all the above desired properties. Some metals can satisfy few properties, some can satisfy few properties, but there are drawbacks in all the materials. So, uh, for VLSI technology engineers, the researchers are looking for the best metal that can satisfy all these properties. Okay, so one approach would be to use different metallizations for different applications. Okay, suppose we want to use a material for gate metallization. In order to make the gate contact in most transistors, we will use different material. In order to make contact metallization, we will use different material. In order to make interconnection metallization, we will use different material. Okay, and for other applications, we will use different materials depending upon the requirement. So, first of all, let us consider what is to be done for gate metallization. So, for gate metallization, polysilicon is used for this purpose. Okay, in order for gate metallization, polysilicon is used. So, gate metallization means uh, this is SiO2 layer and this is the polysilicon layer above which gate contacts are made. Okay, but nowadays our, this is polysilicon layer, polysilicon layer. But nowadays another layer on top of this polysilicon layer is also used in order to decrease the resistance. Okay, and that layer is of refractory metal silicide layer. Okay, so these are the metal silicides that are used on top of the polysilicon nowadays in order to make gate contacts. Okay, so what are these metal silicides that are used? So most common metal silicide that are used is tantalum. Okay, and molybdenum is also used. Tungsten is uh, somewhere tungsten is also used. Okay, so this is the uh, choice of material for gate metallization. Now let's come to the contact metallization. So for contact metallization, aluminium is the choice. Aluminium is used for contact metallization. Why? Because it is uh, easy to process. It has the ability to reduce the native silicon dioxide. Okay, because we know that whenever your wafer will make contact with oxygen, it will form silicon dioxide very rapidly. Okay, so that aluminum has the ability to reduce the native silicon dioxide. Okay, it also have low resistivity. But aluminium has some disadvantages. First one is it has low melting point. Okay, so suppose in some fabrication process, uh, the desired temperature in that process is increasing to the melting point of the aluminium, and we have already uh, done metallization process. Okay, so that will be problem. Now there are some other problems associated with the uh, metallization. Okay, so nowadays we know that in VLSI design, devices are becoming smaller and smaller. So with the reduction in the size of devices, obviously the size of junctions that are formed is also decreasing. So around 2500 angstrom or less junctions are become desirable. So here, whatever metal contacts we are making, they should not lead to spiking shots. Okay, what is the spiking shot? Suppose you are making metal contacts like this. Let's say this is a this is source contact, this is drain contact. This is your semiconductor here, and this is the metal. Okay, and this is your junction. So junction depths are very small also. So spiking shots mean if the metal deep penetrates into the semiconductor. Okay, so already the junction dimensions is very less. Okay, so there may be a short, it can occupy the whole junction. Metal can occupy the whole junction, and if the metal occupy the whole junction, it will make direct contact with the substrate. Okay, whereas it should not do that. So device characteristics will alter, device will not work. Okay, so this is called spiking shots. Spiking shots are commonly observed when aluminium is used as um, contact metallization. Okay. Now there is another problem. So if we want to decrease the area of contacts, means this area, if you want to decrease the area, means everything is decreasing in VLSI design, then we will have to decrease also the area of contact. So if you want to decrease the area of contacts, so it may cause step coverage problem. Okay. uh, if the size of conductors is decreased, okay, the dimensions are decreased, okay, so the current density is reduced, and increased chip temperature promote electromagnetic induced problems in aluminum rather than contacts. So these are the problems that are done in this if we use aluminum. Another thing that we have already discussed is the contact resistance. So contact resistance should be kept small. Okay. So what are the solutions for that? So many solutions have been proposed. We can use dilute silicon aluminum alloy. We can use polysilicon layer between gate source and drain and top level of aluminum. Okay. So polysilicon layer can be used between gate source drain and top level of aluminum. We can use tungsten as well. Silicides can also be used. Okay. So these are the metallization choices.